Hello everyone, my name is Priyanka and I welcome you all to my session. I have posted the question on the board, so let's go for it. The frequencies of two sidebands in an AM wave are 640 kHz and 660 kHz. Find the frequencies of carrier and modulating signal. Alright, so in this question, we are given the frequencies of two sidebands, that is omega c plus omega m is given to us as 660 and omega c minus omega m is given to us as 640. So we have to solve for omega c and omega m. So it's quite simple that we are having two equations and two variables. So simple mathematics, what we can do is we can just add these two equations. So here we can see that these two terms are getting cancelled out. So twice of omega c is equal to 1300. Omega c comes out to be 650 kilohertz. Solving for omega m now, putting the value of omega c in any of these two equations. So let's put it in the first one. 650 plus omega m is equal to 660. So omega m is coming out to be 660 minus 650, which is 10 kilohertz. Alright, so the frequency of the carrier wave comes out to be 650 kilohertz and the frequency of the modulating signal is 10 kilohertz. The next part of the question is to find out the bandwidth of the AM wave, as in the amplitude modulating wave, which is the frequency of lower sideband minus frequency of upper sideband. That means what we have to find out is omega c plus omega m minus omega c minus omega m. So let's solve for it. Omega c plus omega m minus omega c plus omega m. So the bandwidth is equal to twice of omega m, which is equal to twice into 10 that we have just found out, which is equal to 20 kilohertz. So that's the answer for the bandwidth required for amplitude modulation. Hope I was able to help you out with this question. Thank you so much for your time. Bye-bye.